In week 1 of Physics 112, we were introduced to Module 0, 1, and 2. In Module 0, we completed the e-learning orientation provided to Maricopa Community College students for taking online classes. In Module 1, we covered the syllabus, Chapter 2 of the Arduino, which included building the circuit board, and the 3 questions about physics and reality. In Module 2, we responded to other students' answers to these questions and initiated a debate about physics and reality. The next part of Module 2 included a discussion about the Nature of Science article written by Dr. Weaver. In this article, we discussed science, theories, and laws. And as part of my discussion, I agreed with Dr. Weaver that theories were explanations for scientific activities and laws were mathematical proof for those theories. The next agenda item for Module 2 included posting our first NEAT resource. The topic of this NEAT resource was 3D printing, a relatively new technology that has recently been used to build organs, firearms, and other new NASA technologies. For my NEAT resource, I used a YouTube video of bioprinting, a form of 3D printing. This bioprinting uses an inkjet printer type of technology to produce layers of cells in a gel form to produce an organ. Other students posted interesting articles about 3D printing to make organs and basically anything else we could think of. The next agenda item in Module 2 including building the first Arduino circuit in Chapter 1. As I attempted Chapter 1 of the Arduino circuit for the first time, I completed the circuit wrong and was not able to get the light to turn on. However, once I understood what I did wrong and completed the second circuit, the circuit worked and the light was able to turn on with the push of a button. The final objective of Module 2 was to complete the static electricity chapter and the related simulations. In this chapter, we learned how static electricity is formed. Static electricity is charged in several different ways using positive and negative charges, then delivered through ways of shock, lightning bolts, etc. Shock can be delivered in many different magnitudes, including lightning bolts, touching a car, etc. The relationships between these positive and negatively charged atoms are what cause static electricity. After reading the chapter, we used 3 different simulations to help us understand how static electricity works. These simulations included the John Travoltage, balloons, and electric field hockey simulation. The John Travoltage simulation uses friction to induce static electricity in his body, then the charges attract, producing a shock when he touches the doorknob, like so. In the balloons and static electricity simulation, balloons receive the negatively charged particles from the sweater, then the negatively charged particles attract to the positively charged particles on the sweater and the wall, causing the balloon to cling, which is a form of static electricity. Finally, in the electric field hockey simulation, positive and negative charge reactions are used to lead the puck to the goal. Since the puck is positively charged, it attracts to negatively charged reactions, causing static electricity. The lessons we completed this week help us to understand what physics and science are, how static electricity forms in our daily lives, and how to build and understand simple circuits. The lessons on static electricity are especially important in our everyday lives because we now understand exactly how electricity forms when we create friction, induction, conduction, and grounding. We experience the phenomenon of static electricity every day when we put on clothes, touch our car, or see a lightning bolt. Also, the understanding of circuits help us understand how electricity is produced and how the electronics we rely on every day work. This will be beneficial in building or fixing electric parts in our everyday lives. This concludes the Week 1 summary of Physics 112 by Courtney Rothwell.